Proceeding now to case 4, we have integrals of the form tangent to the mu, secant to the nu du, or cotangent to the mu, cosecant to the nu du, where m is a positive odd integer. Okay, so here's the rule, different from cases 1 to 3. What we will factor here is tangent u secant u, or cotangent u cosecant u, and express all the other factors in terms of secant u or cosecant u. Purposely, we are factoring tangent u secant u because we know that this is the derivative of secant. No? So if we have a power of secant and it appears with tangent u secant u, we can of course use the power formula. And what are the identities? Same set of identities. 1 plus tangent squared theta equal to secant squared theta. 1 plus cotangent squared theta equal to cosecant squared theta. Or 1 plus tangent squared u equal to secant squared u. 1 plus cotangent squared u equal to cosecant squared u. The same set of identities. So let us have an example. Say we have tangent cube of, let me see, beta over 3. And then secant to the 4th, beta over 3 d beta. Notice here that the power of secant is 4, which is positive even. So you can evaluate this by using the rule of case 3. But what we are doing now, what we are going to do is we will apply the rule of case 4. Okay? So this will become, we shall factor tangent and secant. So tangent squared beta over 3, secant cube beta over 3, tangent beta over 3, secant beta over 3 d beta. And we will preserve this. So all the rest must be in terms of secant. And tangent squared becomes secant squared beta over 3 minus 1. Tangent squared is secant squared minus 1. Secant cube beta over 3, tangent beta over 3, secant beta over 3 d beta. We'll write this into two integrals. Secant squared times secant cube is secant to the 5th, beta over 3, secant beta over 3, tangent beta over 3 d beta. So do not combine back secant to the 5th, no? We are preserving the association between secant and tangent. So let it remain as 1. Then minus 1 times secant cube is of course secant cube beta over 3, secant beta over 3, o binaliktad na, okay lang yun, secant beta over 3, tangent beta over 3 d beta. So it will not harm us now if I'm going to write it secant tangent, the same. That will be the same, secant tangent. So my u here is, let me use a different color. My u is secant beta over 3, and my du is 1/3 secant beta over 3, tangent beta over 3 d beta. There. The missing term is, the missing constant is 1/3. So 1/3 reciprocal 3. We'll be using the same set of u and du for the second integral. It lacks 1/3, so 3. Okay? Our answer would be 3. power formula will give us secant to the 6 beta over 3 over 6 minus 3. Secant cube will become what? Secant to the 4th beta over 3 over 4 plus c. So that is 3 over 6 or 1 half. Secant to the 6 beta over 3 minus 3 fourths secant to the 4th beta over 3 plus c. Let me just factor the constant. 1/4. 1/4 2 secant to the 6 beta over 3 minus 3 secant to the 4th beta over 3 plus c. And that will be our final answer.